Okay, in this video, we are going to do a complete deep dive into Linux capabilities. Now, a lot of people get confused and think capabilities are just another version of SUID, but in reality, they are actually a completely different thing, and we will understand exactly why. We'll start from the very foundation, understanding what capabilities actually are and why they exist in the first place. Then we'll move into how we can find them on a Linux machine, and most importantly, how we can actually exploit them to escalate our privileges. So by the end of this video, you will have a solid understanding of both the concept and attack. So without any further delay, let's get started. Perfect. So let's start. First of all, we will discuss why the capabilities are not the same as SUID, even though it's both are like the special kind of permission, like giving a specific file or a specific user some special kind of permission to do some activities that a root user can. Okay, and we need to understand because a lot of people get this wrong. SUID is like giving someone a master key. So we have this example. SUID is like giving someone a master key to an entire building, and when someone has that master key, they can literally open every single door. It is either all or nothing. What I mean by this is either the guy has the SUID, the master key, they can open every single door, or either they have nothing. They don't have the SUID, they don't have the master key, and they cannot open any door. So it's all or nothing. And capabilities like giving someone a key that only opens one specific door, not every single door in the building. Okay, so one guy gets the key to the supply closet, another guy, the IT guy, gets the key to the server room, and nobody gets the master key. Like we won't give the master key to this IT guy, which will let him to literally open every single door. Instead, we will give us only single key to the server room, because this guy is the IT guy and he's only supposed to do stuff with the server room. Okay, so nobody gets the master key. The idea is that is the idea behind capabilities, like giving someone the least privileges. Now let's understand the problem. What's the problem with the capability is the problem for us as attacker is this. If a system admin makes a mistake and hands the wrong key to the wrong program or wrong person, we can use that to get root. Like if we understand from this example, let's say the system admin or there is a person who manages all the building, and he just mistakenly give the single key that open a single room to some guy that is not supposed to have. And in Linux term, what this will be, if a system admin who manages all of the Linux machine makes a mistake and hands the wrong key to the wrong person, we can use that to get root. Okay, and one more important thing is when you are trying to find out the Linux binaries, like the command we discussed in the previous video, you won't actually see the capabilities over there in that search command. Instead, they are completely different thing and invisible to the same command that we use for seeing the SUID binaries. And the TryHackMe specifically says neither Vim nor its copy has the SUID bit set or enabled. Vim, as you might know, this is a text editor, so it just means that the SUID is not enabled on the Vim. This privilege escalation vector is therefore not discoverable when enumerating files looking for SUID. So what this means is, let's say the Vim program has some capabilities, okay, but it does not have the SUID enabled. So when we use the command that help us find the SUID binaries, we won't see the Vim program over there. For this specific reason, when we don't see the capabilities when trying to find out for the SUID binaries, this is why we need to understand the capabilities by its own. So hope all of this makes sense. Now let's understand what capabilities actually are with some example. Okay, that was the differentiation between the SUID and the capabilities. So let's understand first of all why we needed the capabilities if we had already the SUID. So Linux has always had a very simple permission model. Like you are either a normal user, you have a least privileges, you cannot do very high level stuff, meaning you have limited privileges, or either you are a root user, meaning you have a higher permission. And because of only of these two permission, we had a problem. Okay, so let's understand the problem. Imagine a program like ping. Okay, ping is something that sends packet out of the machine to the server, to the another server, so that we can check if that server is online or no. You might have used already this in Windows. So to send the network packets, it needs one specific kernel permission. Under the old model, this model it's talking about. The only way to give ping that permission, the one permission that it needed over here, was to enabling the SUID on the ping program. So it means that if we enable the SUID on this ping program, it will have every root power just to use one feature, the specific kernel permission. And that is the problem with it, because the ping program only needs one specific kernel permission, and we are giving the same permission, every permission the root user have. And because of this, we got the capabilities solve this by splitting the root's total power into around 40 individual pieces. Each piece is one specific type of privilege operation. You give the program only the piece it needs. So we divided the root, whatever permission this root user have, we divided that into 40 parts, and each part is represent a different kind of privilege operation. Okay, so let's say again take the example of ping. What we do is ping needs to send raw packet, so we only give it the net raw capabilities. Cap just mean capabilities, net mean network, raw mean the raw packets. So we give it only the permission to only send the raw packets to the ping, instead of giving the root permission or enabling the SUID on this program. Same is the case for a web server needs to use port 80 or any other port. We will only give it the network band service. This will allow it to use any port it wants. So you see right here, we have divided the root permission and divided into very small chunks, and whenever each program, depending on the program, needs some permission, we give it the capabilities that it required. And right here you see no program needs full root anymore. So in practice, if a system admin gives the wrong capabilities to any program, that can also run arbitrary code that is direct path to root for us. This run arbitrary code mean like we have some program that can by its own execute command. So if that program has some capabilities or SUID enable, it can also execute that code or command with its own permission. Okay, so it just means that. Now let's talk about how we can find out the binaries with capabilities. So we have the getcap. This is the tool that reads capability. Okay, and this -r mean recursive search every folder and subfolder, and we are trying to search it start from the very top of the file system in the root directory. And then this, you might already now throw away error messages. So if we don't use this, it will we will get permission denied, like a lot of error in our terminal, and it will be some kind of spam. So we use this to like only get what we want, and because of this we will not get any permission denied error, so our output will be clean. Now I'm gonna do in my own machine. I will show you how we can practically do this, but when we type this same command, we will get something like this. This is one binary, this is the full path of the program ping, and this is another program. We have the vim.basic, and then we have the full path for Python where the Python is, and then we have this another program tar. I think this is some related to the zip files. So when you type this, we will get a list of some program that, and we will also be able to see the capabilities each of the program has. So for this ping program, we can see it has the cap underscore net underscore raw plus ep, and this has the set UID capability. This has the set UID, again the same capabilities, and this has the DAG underscore override capabilities. So you see, first of all, we have the program or the binary full path, the exact path of the program. Then we have the capability it got, and then plus ep. So this is the full, that's the structure. First of all, we have the binary full binary path, this is it, and then we have the capability granted, this is that. Okay, and then the plus, you see after the ep, how the capability is active, is it active and the program can use it or no. I'm gonna explain the capabilities in a moment, but let me tell you shortly. This capability mean it will have the permission to send the raw network packet. This will have the capabilities, this will let the program enable to set the user ID, and if some program has this, it has the ability to set the user ID to even 0, I mean to root. And this is the same capabilities, the set UID. And then we have another capabilities. Now I don't know what this is, but we will we will see in a moment what this capability is able to do. And this plus ep, what this means is we already know this is the full path of the program and this is the capability it has, and then the ep part tell you how the capability is active. So right now we only see the character e and p. E just mean effective, the capability is active right now the moment the program runs. When you see the e character with any capability, it means you don't actually need any extra step to have the capability. It will just start automatically or use the automatically by the program. And the p means the capability is allowed to be used. If we combine both of these together, it means the capability is both allowed and active the instant the program runs. This is the one you want to find, and yep, this is exactly the one that we will be looking for, and this we will be talking about this later, how we will be exploiting these capabilities. Okay, and then we also have the I, which mean inheritable. So let's say this Python program like launches some child processes. So if you see the I with it over here, it means the child process will also get the same capabilities that the parent program has. Okay, and if you see the p without e, just plus p, the capability exists but the program has to explicitly active in its own code. Like you have to take some manual step to enable the capabilities the program has. And the plus I only mean only child processes can inherit in. I think if we have this plus I, it means the capability it has is not active and allowed as well. So it will just get the capability but it won't be active, and we will not be looking for this, and it is usually not directly exploitable. Okay, so right here you see always focus on the plus ep entries. Now we have this thing over here, we have these three different kind of mechanism that gives the permission to the other binaries. First of all, we talked about the pseudo permission, how we will see the pseudo permission for a normal user and how we can exploit them. Then we talked about the SUID binaries by using this command, and it will give a list of SUID enabled binaries. And we also talked about the SUID and how we can exploit them. These are the videos. This is for the SUID one. Okay, how we can find out, and a lot more detail in this video I have covered in this. And in this video I have talked about the pseudo misconfiguration, how we can use the pseudo, how we can see them and how we can exploit them. So if you are interested in these video, just check it out and you will understand and get a lot of stuff from these video. Now the third one we have is the capabilities granted binaries. So I talk about that we use this getcap tool and then -r for recursive search, and then this to find out the program or binary that has some kind of capabilities. Now let's move a bit and we will now talk about the capabilities out of the 40 capabilities. What capabilities we will be focusing on that can be exploited. Below the capabilities which we will be discussing, if you see any of these and with the plus ep, that will be our target. Okay, so first of all we have the capability set uid. So we will now discuss the suid capabilities, but before that I wanna copy this command and paste it here so that you can see what capabilities we have. Okay, so we have one program, the view, another is vim, and another is ping, and another is this one, the mtr dash packet, and also this program, the trace route. And we can also see the capabilities it has. So this view program has the SUID capabilities plus with the EP, and this same capability it has also. And then the ping capabilities, we talk about this in the example. I think this is the same with the EP, and this is the same again. And this is the service band services that like for the web server. Again, this has the EP. So these are all the capabilities right now enabled in this machine for this program. Okay, now let's discuss the full capabilities, this one specifically. Set UID stands for the set user ID. Normally only root can change a process user ID to root, which is 0. But if you have this set UID capabilities, it will give you that same power. Like you can literally change the process ID to 0 or any other user ID. Normally we want to set the process ID to 0 because it is a root user and root user can do any single thing. So if I tell you the same thing in simple term, this will just mean whatever program has the SUID set SUID capability enabled, it will just mean the program is allowed to say I am now a root user and the kernel will accept it. If that program can also run some kind of code we can control, like so we can tell this program to set our ID to 0 and it will open a new shell and that new shell will run as root, meaning the ID of that shell the effective ID of that shell will be 0. So it is dangerous because it has no visible SUID enabled, but the capability it has, it will give us the instant root shell. Now these are the commands. Let's say if the SUID set your SUID capabilities enabled on Python 3, Vim or any of these programs, we can use the exact command to give us a shell that will have the root privileges. And down here I have talked about this. Let me go over here this. So you can go to the GTFOBin. We will talk about this in a moment, but you can go to this GTFOBin and search for the program. Okay, so let's say we have the set UID enable on Python 3. I'm gonna search for the Python and we have this Python. Let me click on this and you see right here the capabilities. If the capability is able to give you the root shell, you will see the capabilities in this shell category. Okay, so I'm just gonna click on this and it gave me the command that if I copy this and run it on machine, if the Python program has the set UID capabilities, only after that it will give me a shell that will have the root permission. Okay, so this is how you search every single program. Come out here to the GTFOBin and see if you can exploit that or no. And for the Vim, this is the same stuff. The command you will get, just come to the GTFOBin and search for the program. Let's also understand this specific command in a bit detail. So this is the command we have: the python 3 -cmin run the following as Python code directly, and we don't actually need any file. Okay, so we then put the command in quotes. We then using this we load the operating system module. This gives the system level function which gives access to the system level function. Okay, and then we call the set UID, which is a system level function that can only be called by a root user. So as you know, this guy has the set UID capability. So this means this just tells the kernel set our user ID to 0. This only works because this capability is granted to this Python program, and if a normal user try this, they will just get operation not permitted. Okay, so this will be used to set the UID calling the set UID function, and this right here just this will open the bash shell. Okay, and since our ID is 0 in this step, it will run the bash shell will run as root. Okay, so this is how the SUID SUID can be exploited if any of these program can have. And now let's talk about this another capabilities, the file permission bypass. Okay, we have a lot of capabilities. I will just go through the tag capability. Tag or write the DAC stand for discretionary access control, the standard Linux file permission system. The read, write, execute, you see in when we type this we see some kind of this stuff. So I think when some program has these capabilities, it will completely ignore these permission, means ignore it completely. Normally if let's say we have a file that has the this permission, this is the octal notation of permission. This just mean the user can only read the file. Okay, and the other user, the group, and then the other user can not read, write or execute that file. You cannot read it as a regular user. Yep, so that's what I talk about. You see right here, if the file is owned by root with these permission, the normal user won't be able to read that file as a regular user. So let's say if you are a regular user, but that same file has this DHC override capabilities, it will be able to read, the normal user will be able to read that file which is owned by the root. Okay, not only just read but also write or execute any file on the system regardless of who owns it or what the permission says. So I think it just simply mean whatever program or whatever file have this capability, it will just mean it will kind of ignore all of these permission and kind of it will be free for all without, like we can say it has no permission and it's free for anyone to use it any however they want. I think it's something like that. So why it's dangerous is this shadow file you already know contains hash password for every user, and normally it is not readable by a regular user, but if some program or some binaries has this capabilities, it will be able to read the shadow file and we can get the hashes and later crack it using the John tool on another machine. And not only read but we can also write to any file if we have this capability. So yep, including this etc password file. So if we can write to this file with having this capabilities, we can also create a new user if we can write to this specific file with this capability. And another thing is we can also open or write to this sudo file which contains about the sudo command that a normal or regular user can execute. So let's say we have regular user, okay, and we can open this file if we have this permission, the sudo file. We can open this file and we can literally give ourselves the sudo permission and we will just type we are someone that we can write and we will give ourselves the sudo permission, meaning we will have the normal user will have the sudo permission then, and if we have the sudo permission the system is in our hand then. Okay, so let's say if the tar program this is something related to the zip file, if it has the DSC override capabilities, like for example this let me show you. So if you type the getcap command and you get something like this, the user bin tar program, and you see in front of it like this, okay, it means the tar program has this capabilities and it is active and allowed. Okay, so I'm gonna scroll a bit and tell you something. So we will use this tar and use these flag. This is related to the tar program. Okay, so I will explain these what these two mean. Okay, assuming the it has that capability. So when you type this program with these flag with the shadow.tar and then specifying the shadow file exact location. So this is the tool exact tool. This means create a new archive, and we mean verbose show me what you are doing. Like in plain English, if I explain this to you, we are just telling the Linux that hey tar, telling this program hey tar, create an archive called shadow.tar and put ADC's shadow what the content of this file in this shadow.tar inside it. Okay, so it just means like creating another file, another zip file with by extracting the content of the original shadow file. Okay, and then we use this another command, this one. Okay, I'm explaining this one now. This one mean hey tar, extract everything from shadow.tar file, show me what you are doing. Like it will then show us what's inside in the tar file. Okay, unpacking files out of the archive, and it means packing the file into an archive. So this two command just mean that. Okay, and if this is about reading the shadow file and this one is about creating a new user, if you can write to the password file, so you will use the OpenSSL tool to create a hash pass of a new user. Okay, and once you create that hash, we will then open the password file with any tool that has the DHC override capability. We will open that password file and put a new line, write a new line at the end of it. So we will put something like this line. We will specify the username and then the hash password we created over here using this OpenSSL tool, and then we will set the user to root and the user ID to 0, the group ID to 0, and the shell. Okay, so once we do this and save the file and type this su command with the user we created, it will then ask from us the password. Once we enter the password, the user that user will be a root user. Okay, and if the Python program has that capabilities, we can use this command to read any single file, even the shadow file, the password file. Similar to this, I hope you understand this capability. I have explained very nicely. Now let's talk about the set GID. This is kind of similar to the set UID, but in this we are setting the group ID. Okay, so there are some certain sensitive files that are group readable but not word readable, that not everybody can read those files. For example, this shadow file, we have the shadow file, we just talk about that file has the hashes of all of the user, and sometimes it is readable by the shadow group. We have a group called shadow. Even if you are regular user, but if you belong to this group, if your normal user belongs to this group, you will be able to read the shadow file. Okay, so when we have the set GID permission capability, what we can do is we can set our group ID, our as a regular user we can set our GID to the shadow group. So as a normal user we will set our group to shadow, and once our group is set to shadow, we will be able to read the shadow file, and we will then list the content of this, copy any of the hash, specifically the root hash, and then we will use the John tool to crack the password of the root. Okay, so if the Python program has the SCID, we can use this specific command to set our group ID. Okay, we can also set our group ID to 0, which means root 0 is the root group ID. And if we also have the set UID capabilities, we can literally set our group and the user IDs to 0. So I'm just gonna, let's say you have this capabilities and you want to see all of the group, let's say the I mean like all of the group present in this Linux machine. So you will just type the get, this will list the content of the group is in this directory. Okay, so once I press enter, we will be able to see all of the group. So these are all of the group. Right here you see this is the shadow group, and we have a lot more groups. And these are the exact ID, the number you see. So for the shadow, the group ID of the shadow group is 42. So we will just, if we have the set GID capabilities, we can literally just type the 42 over here, and our group will be the shadow group, and we will be able to read this shadow file. Now let's talk about the another capability, system admin capability. So this means system administrator operation. This is a very broad bucket capability that covers so many of different privilege operation. In simple terms, this one is so powerful that security researchers call it the new root. It lets a program do things like mount and mount file system, change kernel setting, and much more. If any program has this system administrator capabilities, and that program can also run some kind of code, has the capability to run codes, that means we can treat it as same as the root access. If you have the set UID capability, you can only do one specific thing, even though it will let you root access, but the system administrator cover a huge range of kernel operation. I mean, if any of the program has this specific capabilities, what you're gonna do is come to this GTFOBin and then either type the specific program name or click on this capabilities. Okay, so let's say I'm gonna click on this specific program. Okay, and if I click on the capabilities, because we are talking about the capabilities and talking about how we can exploit capabilities, so I click on this and give me this command, and this command will only work if you have this DHC override capabilities. So it was for this the one we talked about, but you will look what program has this capability enabled. You will just come over here, type the program name and click on it. Okay, and then look for what you can do with that capabilities. Another example is if I scroll, I click on this Python program in this GTFOBin, and this is shell category, this is reverse shell. We see the capabilities section here. Okay, it just means you need this specific capability to run this command, and we don't see anything over here, the capabilities section in reverse shell. For file write as well, for file read we don't see, file for upload we also don't see, for download we also don't see, but for library load, we see the capabilities section. I clicked on this and you see right here we got another command, but it says you need this specific capability. So this is how whenever you come across any program that has any capability, just come over here, search it, and just scroll through it and see what you can do with it and how you can do with it. And then we have the cap change ownership binary change owner. Normally only root can change who owns a file. Okay, so if any binary, if any program has this permission, you can literally change the owner of any of the file and then do whatever you want. You can modify it, read it, or anything you want. Like let's say we have this permission as a normal user, some binary or some program had this, we can make this shadow file owned by a normal user, and once we make ourselves owner, we can then give ourselves permission. Usually you will not be able to like read or write to it. You will then use another separate command once you become the owner. The command which you will use to give yourself read, write, execute permission is change mode. So you will give yourself read and write and execute permission, and you will open the file, and let's say we will do for this file, we will just give ourselves all of the sudo permission, and that's how it works. Again, go to GTFOBins and just search for there. If it has not, just ask from the AI. And this one I think it's a bit more simple. You can make yourself the owner of this file, and then you can edit this file giving yourself all of the sudo permission. And then we have these two permission as well, capabilities actually. So it means this is what ping and TCP use this capability. It's generally a legitimate capability and directly not exploitable, so we cannot, I think, exploit this, right? The main one that we'll be focusing on, the above that I told you, the change ownership and this set GID, set UID, and this TAC override. These capabilities are very important to like keep like to notice. Again, this one as well not exploitable. This is what web server use so they can run on port 80 or whatever port they wants to run. Okay, so if you see these any of these two capabilities, it's not a privilege escalation path, so you will just move on from these. Now we have the decision flow. How, like, let me zoom a bit, and if you find binaries with capabilities, okay, let's say we type the getcap command and we see some capabilities, our next question should be, does it have the plus ep, is it active and allowed the capabilities on that specific program? If no, it is a low priority and we will move from that, because it is not allowed. Either the capability is not allowed for that program or it is not active. If it has the plus if any of the program or binary has this plus ep, it is then worth to explore a bit more. Once we see the capabilities that has this, okay, we will then look for, is this the set UID capability, this take override capability, set GID, system admin, or the change ownership capability? If you see none of them, it is a low priority. Again, just I think it's best to move on from this. And if you see from any of these, we will then come over here. We can do a lot. Like if we have the change ownership, we can, as I told you, change ownership or change the owner of any file. This will give us a lot more privileges. This will set the group ID, this will override, this will like ignore the file permission, and this will set the UID. And over here, as I told you earlier, we will come to this part. Just whatever binary you get, whatever permission it has, just come to GTFOBin, and I hope I explained the very important ones already, so you don't actually need more capabilities. And to see, as I told you earlier, we have divided the root permission, root capability into 40 Linux capabilities, like a small chunks of permission. If you are interested to find out or read about all of the 40 capabilities, just come over here, click on this line, and click on this link. You will see all of these capabilities. Okay, but the important one is these are the one that I have talked about. And then it just said that why we don't get the capabilities when we are searching for the SUID. So it simple term, it means they are using the different file system, so that's why we don't get them. Okay, and down here it says managing capability. If we have the root access, we can create we can give any capabilities to any program, or like delete or remove the any capability from any program, like kind of managing the capabilities. So let me clear this and let's see what capabilities we have. So I will just type first of all bash, and then the tool we will be using is getcap, get capabilities -r to search recursively, and then in the root directory, this is the like the very top directory, and then it will search throughout, and then we need to type this so that we don't see any error. So let's do this and up. So we have this program, okay, and what I'm gonna do is let's get the root access, and I think I'm gonna go with any of these two files because these both have the set UID permission. So let me scroll. Earlier we talked about if Vim has the SUID capabilities, we will just use this command and get the root shell. So we now have this, and let me just copy this command and see if we can get the root access or no. Okay, so let me copy this command because we have the set UID enabled on the Vim. Okay, so I'm just gonna type the bash again and then do this and then send the command. So it just do something like this, some weird thing. It will open me the root shell, but I don't understand what is going on. So I'm gonna stop this. Instead I will use the view program. Okay, so we also got the view that has the SUID enable, SUID capability enable. Getcap, let me show you again. Getcap -r this and to tell. Okay, so you see right here this view program has this enable, and I went to Claude and asked him to give me the exploit. So we got this already, and this is the exploit. Let's try if we can get the root shell or no. I'm gonna copy this and paste it here. Okay, here I am doing some debugging because the command did not work. I'm trying to find the fix just by copying the result and going to the Claude, and Claude is giving me the commands and I'm just following that. Okay, so I went through a lot of debugging. You can see right. Let me show you actually. So first of all I tried it in the image. I was getting like this. Okay, so it says you don't have the permission, but actually I had the permission. The set UID capability was enabled, so I got a lot of problem. Finally it gave me this specific command. Okay, so let me run this command. I will use the Vim, okay, instead of the view again. So now if I type this command, it will then open the Vim editor and also give me the root shell. Let me press enter and see. Okay, so it does something like this, and we got the root shell right here. You can see if I type the id command, you see it is a root user. Okay, so that's how it works if you have the set UID capability enabled. Okay, since we have the root, now what we can do is managing the capabilities. So if you want to manage the capabilities, you see we use this to get the if the capabilities, what are the binaries that has the capability, some kind of capabilities. If you want to enable capability or give some capability to any of the binary, we will type the set cap and the capability. Okay, and then the flag that we talk about, either +ep only, +e only, or +p or +i, and then the exact program location. So this is the example. We want to give the set UID capability to this specific Python program. That's how it works. And if you want to remove the capabilities you have given or already they are, so all you will do is set cap again, but instead you will now type the -r, which means remove all capabilities, and specify the exact location of the program, and then again type the get cap to see the capability to verify it is gone or no. Okay, so now we will find out these answer. This is the lab I was doing. How many binaries have the set capability? So I think, is it asking for our all capabilities or just the set UID capability or set GID? Let's try. Okay, so I'm gonna type so I type this, and I think these are the two set capabilities. Let's see, is it asking for all of the binaries? Let's count 1 2 3 4 5 6. Let's try 6. Yep, it was asking about how many binaries have the some kind of capabilities, and I gonna click on this as well. And now we need to find out the flag for. Okay, so let's find out the location of it. First of all, I'm gonna do this flag for .txt and then do like this. Okay, this is the location and home window of flag 4. I'm just gonna type this exact location and use the cap so that I can see the content. Okay, so cat home view window and flag 4.txt. So we got, I typed this, but something is weird in this terminal, the root one. I have honestly typed this exact thing with the cat and I got this. At least I got the, I don't see the command that I type, but I got the answer. Even though I am a root, but something is weird with this shell. I don't know why. In normal VM it will be okay, I think. So the flag we have is thm. Let me type here thm 9349 9349 and then 843. Yep. So I'm gonna copy this over here and paste it here. Perfect, we also got this and now we need to find this one. Okay, then we have this question. I honestly don't understand what this means, so I asked Claude and it is kind of asking is we found out view program can give us root using the set capability, set UI capability, but they are asking what other binary also has this set UID capability. So we know that which is one is view and another is vim. So the okay, so first of all the first one was vim and then they are kind of doing it in a sequence. First we got the vim, it can we can use the set uid capability of vim, and then another we have is the view. So they are actually asking if we notice the view as well or no, just the vim. So yep, this is the correct answer. So let's summarize all of this now. So first of all, what we did is we understood what Linux capabilities actually are and why they are completely different from SUID. And as we discussed SUID in previous video that I told you to watch out, it's like giving a program a master key, all or nothing. We talk about what this means, and then we talk about capabilities on the other hand are much more specific. Instead of giving a program full root power, full root permission, you can give it only one specific permission it actually needs. And the tricky part about that is you cannot actually find the capabilities with the ls, or like when you are searching for the SUID binaries, you won't actually be able to see the capabilities. Instead you will use the getcap specifically for this. Okay, and then we talk about actually how we can use the getcap tool to find out the binaries that have some kind of capabilities. And also I think we also talk about how we can read the output that we get from this. And besides that, we also talk about the plus EP or only E or P or the I. We talk about these flags as well. So hope you understand what those flags mean, the E and P. And the very important we need to look for is the plus EP, as I told you earlier. And then we talked about and then we discussed the dangerous capabilities, the all of the dangers that capabilities that we should be focusing on. There were a bunch of them. Okay, these are the DAC override, the set UID override, the set UID capability, the S set GID, and a bunch more. And then I have also talked about how you can go to GTFOBin and search for the binaries that you get that has some kind of capabilities. So this is basically how we try to find out the capabilities and actually how we can exploit them, whether it's in the CTF or TryHackMe or in real pen testing. And in the next video we're gonna talk about cron job, like what they are and how we can find them and how we can actually exploit them. Okay, so hope you understand all of this that I have explained, and if you have any kind of question, any confusion, let me know in the comments. I will make sure to answer you. See you in the next video.